Alright, so a very good morning to all of you, and today we are live streaming from In5 and we are here with another workshop. So today's workshop is about making a smart surveillance camera using Raspberry Pi. Now if you have ever wanted to buy your own surveillance camera system or something like that, and could not buy it because maybe it was expensive or for any other reason, you're gonna love today's workshop. So in today's workshop we'll build a smart camera using only Raspberry Pi, and we'll do some Python coding using OpenCV, and yeah, we'll pretty much build it from scratch. So let's get on with it. So let's start. Okay. So let's start by talking a little about the assembly. So assembly is basically a smart lab based out of In5 since December 2014. And over the course of over 5 years, we have provided around 250 free workshops. Now these workshops are divided into 3 categories: hack, code, and data science. Now workshops like today's, which deal with embedded systems, hardware, IoT, come under the hack category. Workshops dealing with coding projects that are specifically like all coding projects using APIs, gaming projects come under the code category. And data science workshops are quite self-explanatory. They deal with topics that are related to machine learning, AI, big data, and everything of that sort. Now our target audience are students, professionals, and entrepreneurs, but we are more than happy to welcome anyone who is interested in our workshops. Now we focus on smart technology and its practical applications, and you can know more about us on our forums, which is members.theassembly.ae. Don't forget to tag us on our social media. You can check out our social media handles from this on the screen, and you can tag us on them. Now for today's workshop, we are going to be using OpenCV along with Python to code a Raspberry Pi smart surveillance camera. Now for those of you who don't know what OpenCV is, OpenCV stands for Open Source Computer Vision Library, and it's a library that is mainly used for real-time computer vision. And it was originally developed by Intel, and then it is still kind of developed by or maintained by Intel, because it was supported by Willow Garage and then by ITSEs, and now ITSEs is also acquired by Intel, so it's basically the same. And the library is free to use, so that's one of the big advantages of OpenCV. You don't have to pay to use it, it's free for everyone to use. Now today we'll be using, now there are several detection models that are pre-built into or we can use with OpenCV. So today we'll look at 3 of these models. The first one over here on the left is the full body classifier, the middle one is the face detection model, and the third one is upper body detection model. So you'll understand more about these when we go to the coding part, and then you'll know why we have 3 different models, and then it's very simple to change from one model to another if you want to do a different type of detection. So what are the requirements for today? The requirements are pretty simple. You need a Raspberry Pi connected to the internet. So if you have a Raspberry Pi 3 or above, then it already has a pre-built Wi-Fi module which you can use to connect to the Wi-Fi. And if you have an older version of Raspberry Pi, then you can connect it through Ethernet. And of course you'll need the Raspberry Pi camera module and VNC viewer if you don't have access to monitor or monitor keyboard. So if you don't want, VNC is basically a team viewer for Raspberry Pi. So if you want to access or control your Raspberry Pi without having to, with just a single USB cable, then you can do that using VNC. So VNC is just like a TeamViewer version. So yeah, without further ado, let's get started. Okay, so now we'll head over to the hardware section and see how everything is connected on the Raspberry Pi. So over here we have our Raspberry Pi, So I have connected the Raspberry Pi camera module already, but one thing you need to make sure is when connecting the Raspberry Pi camera module, make sure that the silver lines of the Raspberry Pi camera module are facing towards the HDMI cable, and then this is just the blue wire is just the power cable going from the Raspberry coming from my laptop or any other power source for that matter to the Raspberry Pi. And then you don't need to connect the HDMI cables and the mouse and the other USB cables if you're using VNC. However, you'll need to set them up first time because you need to enable VNC interface on your Raspberry Pi. Now let's shift to our VNC viewer. So over here we have our VNC. Now what we'll do here is, first, if you assuming that you are using Raspberry Pi or using Raspberry Pi camera for the first time, you would want to go to Preferences, Raspberry Pi Configuration, and wait for it to open. And then once you are here, go to the interface section and make sure you have enabled camera and VNC. So these are the two things that you want to enable. So if you don't enable camera, you won't be able to use the Raspberry Pi camera, and you must enable VNC if you want to like connect to your Raspberry Pi from your laptop, let's say, for that matter. So do that, and if you do that, it will ask you to restart your Raspberry Pi. Go ahead and do that. And then how we can connect to the Raspberry Pi using VNC is pretty simple after that. So you just type in ifconfig and then look for the IP address of your Raspberry Pi. So mine is somewhat like this. Then just type this Raspberry Pi this IP address onto your VNC viewer on your laptop, and then you can start using or controlling your Raspberry Pi from your laptop. Now we'll need some libraries for this project for this workshop today. So of course we'll start with the most important one, which is the OpenCV. So now there are a few different ways to install OpenCV, and some of them take quite a long time, and some of them are like, if you want to install the complete version, it's very long, but for us we are fine with the basic version. So we'll go ahead and type in sudo apt-get install python 3 -opencv, and we'll be using Python 3 for our workshop today, so that's why we said Python 3 -opencv. So I get this message saying Python 3 opencv is already the newest version. So because I have already installed it on my Raspberry Pi before, but for you it will show you a progress bar, and then it will download gradually, and it shouldn't take more than a couple of minutes or 5 minutes at the most. Then there are some other requirements as well, so we will install them using pip. So we'll say sudo pip3 install imutils. Now again, all these libraries I have pre-installed on my Raspberry Pi, so most of them all of them will tell me that okay, the requirement is already satisfied, but I'm just going through this step so that you guys can follow along. And so yeah, there is imutils, and then another library that we need to install is Flask. So now Flask, so basically Flask will allow us to set up a web server so that we can have live streaming of our camera over the network. So we can maybe see our Raspberry Pi from our, like, the output of the Raspberry Pi camera from our laptops. Then we'll go ahead and install something called Pi camera, and then within square brackets array. And also in today's session we'll be using OpenCV and Python to detect the motion. So we'll detect if a person is moving around in our house, let's say in a restricted area that we don't want them to be. So we can send an email notification notifying the user that okay, there is a motion detected, and then maybe he can check that out. So the last thing we need to install is Flask basic auth, and make sure you type in the same way I am typing, keeping in mind those capital letters. And we want to install the 0.2.0 version. So some of these installations take some time, but eventually we'll get them. Okay, let me just undo this. Okay, so now I have this folder created, and all the codes and everything for today's session will be there on our GitHub page soon, so you can go ahead and download. You will be able to download it from there. And now let me go into our camera folder, so I can just show you what all is in there. So we have a few folders over here. So the first folder is our models folder. So this is what will contain the models, the detection models that I was talking about earlier in the presentation. We have the upper body, upper recognition model, full body recognition model, and face recognition model. Now we can easily switch between these models in our code, so we'll go through that also. And then we'll have camera.py, mail.py, and then main.py. so these two classes will be called all together from main.py. And templates folder, as you might be able to guess, this will contain the HTML text index.html for our web server. So let's say when we are creating a web page, that is the code for that we will be typing in here. So I have already typed in the code for here, which is pretty simple, yeah. So we have this HTML opening and starting tags, then we have the head and the body tags. So we have a title saying Raspberry Pi surveillance camera, and then within the body tag we have an h1 which says Raspberry Pi surveillance camera. And the only thing important over here is within the body tag we have an image tag which has an ID of bg, and then source. Yes, this is something you might want to do. So source is within curly brackets url_4, and then video feed. Video feed is the name which we assign in our Python code, so just keep this same if you are following along. And then width and height you can change according to your own preferences, so this is something that you can play around with. So yeah, let's start with camera.py. So let's open up camera.py. so they are all empty, so we can start typing in code over here. So first we'll import some basic libraries, import some stuff that we'll need in the code. So we'll import cv2, then we so we'll type in from imutils dot video dot py video stream, import py video stream. Okay, then we'll import imutils, then import time, and finally import numpy. So import numpy as np. Okay, so now let's get started with the good part of the code, so interesting part of the code. So we'll create a class. So we'll name our class video camera. So we have class video camera, and then it takes object, then we can start. So yeah, and make sure you follow me, follow the indentation. So either if you are using 4 spaces, use 4 spaces. If you are using tab, then you make consistent use of whatever spacing or indentation you are using. So we'll create the init function or the constructor, and that init will take just the self, and inside the init will initialize, we'll say self dot, will start the video stream. So vs for video stream, self dot vs equals, so pi video stream dot start. So this is, we are starting our video stream. Then we can allow some time for it to start, so we can just have time dot sleep for a couple of seconds to allow the camera to warm up and start. So yeah, then we'll create the destructor method, so def, and then, okay, wait, I forgot the space over here. Yeah, def, and then we have the del, and this also takes self, and over here we'll just tidy up and clean up, or what you call, we'll clean up the resources that were previously being used. So self dot vs dot stop. Now we'll create some methods to get the detections and get frames one after the other. So first we'll type in the method called getFrame, which we will use to get the frames one by one. So this also will take self, and then okay. So we'll create a variable called frame and then store in the frame from the video. So we'll the self dot vs dot read, so this will get us the current frame, and then we can say ret comma jpeg equals cv2 dot im encode, and then encode it to jpeg format. So this is, we are encoding it to the jpeg format. So dot jpg, sorry, and then what do we want to encode is the frame, and then finally we can return our jpeg dot 2 bytes. So this will return the jpeg dot 2 bytes. Okay, so now for the final method of this class, we'll have a method called getObject. So this will check for, so if this will check for, if an object is detected or not, and then if an object is detected, it will create a bounding box around that object. So yeah, let's start with that. So we'll create a variable. Let's first define the function itself. So def get underscore object, and we'll pass in self as an argument, and okay. So we'll create a variable called found objects, and then we'll initialize it to false. So initially we have no objects that have been found, and we'll only make this variable true if we detect an object. So, and then we can again copy our frame. So frame equals, we create self dot vs dot read, and then dot copy. So this will get us a copy of our frame. Then as for most of the or whatever, or say how you call that, so any of the detection, or whenever you want to play around with images in OpenCV, it is good practice to convert them to grayscale, or so we'll just convert this to grayscale and name it gray. So gray equals, so there is an inbuilt method in OpenCV to convert from RGB to grayscale, or whatever the color scheme, to grayscale. So cvt color, and then we'll convert the frame to cv2 dot color underscore bgr to gray. So this will convert it from blue, green and red channels to just black and white, so grayscale. This will convert our image to a grayscale image. Then we can give some properties to the objects. We can create a variable called objects, and then we can say classifier dot detect multiscale, and then within that we can pass in. Okay, so here we have gray, or we can just go back here. Yeah, so gray. So this is, we are passing in our image, then we are giving the scale factor to scale the image. So our scale factor will be 1.1. You can play around with this setting and see whichever works best for you, but I hope this will work fine for the majority of you, or if not everyone. And then the minimum neighbors will be 5, and minimum size. So what we are trying to do over here is essentially, whenever we make a detection, we need to give in all these parameters to make sure that we don't get false detections, or we don't get detections that are too close together and things like that. So just that, and then minimum size of 30 by 30, so 30 comma 30, and then we have finally flags. So flags equals cv2 dot cascade underscore scale underscore image. So yeah, finally we are done with the objects, and we can go ahead and create our if statement to check if we detect an object, then we make the variable true, otherwise no. So if we check the length of the object, so if any objects are detected, they will be populated in the objects. So if the length of object is greater than 0, that means some of the our detections are made. So if length of objects is greater than 0, then what we can do is we can say found underscore objects equals true. Let me just see if I spelled found objects correctly. Yep, okay, so we're good here. Then what we want to do now is we want to draw a bounding box around the detection. So let's say if it detects a face, then we want a bounding box to be drawn on the face. So that is what we'll do now. So we'll create a for loop for that. So for x, y, w, h, x comma y comma w comma h. So we need 4 coordinates for the rectangle. So for the starting point, the ending point, the height, and the okay, so wait, we'll go as I go along with the code. I'll explain what I mean here. So for x, y, w, h in objects, cv2 dot rectangle, and I didn't indent this, so this should be here. Yep, cv2 dot rectangle, and then first thing we want it to be drawn on the frame, so we pass in the frame, and then second is we pass in the starting coordinates for the rectangle. So this is the top left coordinates of the rectangle, so which will be x comma y, and then we have the ending coordinates or the bottom right coordinates for the rectangle, which will be x plus w and y plus h. So for the x coordinate we will have x plus w, so this, which basically means the starting point of the rectangle plus the width of the detection, and then for the y we have y plus h, the height. And then final parameter is the color that we want, not the final one, the second last, we want the color that we want to give into our bounding box. So we'll give in 0, 255, 0. So this will be a green bounding box. So it starts from BGR. So blue is 0, green is 255, R is 0. So this will be a green bounding box. And then finally we have the size of the bounding box. So I'll give it a 2. And then finally we will come back here and then say ret, jpeg equals cv2.imencode. Okay, I think I spelled it wrong. Yeah, imencode, and we can again type in jpeg, jpg, or .jpg for that matter, .jpg, and then frame, and then finally we can just return all of this. We can return the frame. So return, and then within the we can pass this. So jpeg dot 2 bytes and found object. So we will return 2 parameters, or 2 variables for that matter. So we have jpeg dot 2 bytes and found objects. Okay, so this 2 bytes needs parentheses, which I forgot. Let me just quickly check if I made any other mistake while typing in. So looks correct, but hopefully we won't get any error. So now we're done with camera.py. Now let's go ahead and open up our mail.py. So in mail.py we will type in the code for sending the user an email address, and sorry, not an email address, an email if there is a detection made, along with the image. So let's do that as well. So let's open up mail.py, and again there are a few imports that we need to make. So first we'll start off by importing smtplib, which is a library which allows us to send emails. So SMTP stands for Simple Mail Transfer Protocol, and it is used to send emails. Then we will also get from email.mime.multipart import mime.multipart, and then I can just maybe copy this and paste it down there. So we have a few imports from here. So yeah, I'll just copy it here. So we have from email.mime.text import mime text. So we'll change this over here, mime text. Then we have from email.mime.image import mime image. So these are basically used to construct a message and send it for the email. So over here we'll create some variables to store our to email and from email. So let's do that. Okay, so over here we can type in from email, okay, double E, from email equals, and then just type in your email as a string. And it works with Gmail account, so make sure you have a Gmail account for that. And when you're doing this, you might want to also make sure that you have allowed for less secure apps on your Gmail account. So go ahead, if you haven't done that, it won't work. So you need to make sure that you go to your Google account settings and allow less secure apps. You can just simply search for Google, on Google you can search less secure apps Google account, and then turn it on for your account. Also, we'll store the email password. So what you might want to do over here is you might want to generate an app password using Google app passwords. So that will allow you to store passwords, that will generate a temporary 16-digit password, I guess, for you, so that you don't have to type in, or what do you say, you don't have to use your own password every time in plain text. So let me just quickly copy that and paste it in here. Yep, so this is done. And then finally the two emails. So I'll just send an email to myself. So I'll just copy the same email and paste it over here. Alright, and then we have the send email method, which is pretty straightforward. Def email, and then the only parameter it takes is the image, which is the image that is captured or taken when a detection is made. So okay, let me go back there and wait. I'll just copy all this and paste it here. So yes, we have this over here, and this code has 4 space bars as indentation, so I'll just keep that. Okay, so I'll just go through this code and explain what it does. So this is, we are creating a message to be sent in our email. So we have the message root subject. So this is the subject of our email, which is security update. Then we have the from email, which is just from email. So we created a variable on top over here, from email. So this is the same one over here. Then we have to email, which is also stored in a variable, and then we can just remove this part, we don't need it. And then message alternative, which we can have motion detected. Then this part over here, you want to this is the part where we have the image from the HTML, and this is, and then finally we have the SMTP connections. So we connect to the SMTP server of Gmail on port 587. Then we start TLS. So TLS is for encrypting our communication. Then we log in using our email and email password, and then finally we send the email, which has, so we have from email to email, and then the message itself. And then once we're done with all that, we can quit the server. So we can say smtp.quit, which helps to tidy up or clean up the resources that were assigned to this process, and this helps in freeing up space. And you should always make sure that you clean up after you have opened up a process. So, and now for the final part, we will go to main.py. So our main.py is where we are going to use our mail.py as well as our camera.py, and we'll type in the code for our web server as well. So it will have, so we have a lot of imports over here. So we have import cv2, then we have import sys, then we have from mail. So now we are importing from the file that we just created. So from mail, import send mail. So this function that we just created over there, we're importing that. Then we'll import from Flask, import Flask, and also render template. So render template allows us to render a template. So yeah, it literally allows us to render a template. So we can, by using this, we'll be able to render the index.html onto our web pages. And then finally we have response. Also we'll import from the camera file that we just created. So we created camera.py, and then from camera we will import from video camera. Okay, caps is on. Okay, then we'll import time, and finally import threading. Why we are importing threading is we'll make this a multi-threaded process, so that the getting or the detection is done in the background and it doesn't affect the servers running, or and it doesn't block it. So we'll use threading as well. Then we'll create email update interval. So this is basically to have a gap between, or how frequently you want emails to be sent. Let's say if you place your camera somewhere where there is a lot of motion, or you pass through every time when you are in your home, and you don't want emails to be, you don't want your inbox to be spammed with these emails. So you can create you can use this variable to set a time limit as to how frequently you want your emails. Okay, let's go back to our editor. Yeah, so this variable will create email update interval, and then we'll set it to 600, so 10 minutes, and we only want an email within 10 minutes. So you can change this according to whatever you feel like, but I just have it at 600. Then we'll create a video camera object. So we'll say video underscore camera equals video camera. Then we have object classifier. So this is where we use our models that I showed you in the folder, and this is where we actually pass them. So this is what we'll do. So object will equal to, so we'll create object classifier, and that will be equal to cv2 dot cascade classifier, and then within the cascade classifier we pass in the path for our models. So the first one, so since it is in a folder called models, so as you can see we have models and then we have the face. So might as well I'll just go to rename and then copy the name, copy this, okay, come back here, and then since it is in a different folder, we'll type in the name of the folder, model / and then the name of the detection model itself. So right now we don't want the full body, we'll use the facial recognition, because for full body I'll need to move around here and there, but facial recognition you could easily see how it works. It works the same way for other models as well. In case you want to use some different model, you just change the name over here and the rest everything stays the same. So yeah, we do this, and then we create the Flask variable. So we create app equals Flask, and this takes name. Then we have app.config. So what we want to do is we don't want anyone to access our camera feed. We only want authorized users who have the username and password to be able to log on and see the camera feed for security purposes. So we'll do that using, so as you might remember, we imported a library called basic auth. Okay, I forgot to import it here as well, so let's go ahead and do that. So from Flask underscore basic auth, import basic auth. So this will allow us to have that security feature I was talking about. So we'll say app.config and we'll have square brackets, and then we'll type in within, so all caps, so we'll have basic underscore auth underscore username and equals to, you can give, now this is something that you might want to change, so this is for your own use. So this is for, like, for my case I'm using the username as user itself, but you'll want to change it to something that you can easily remember but others can't guess, so something that is easy to remember but hard to guess. And then app.config, instead of username this time we'll have password, so we'll have password, okay, my bad. And then same is the case with password, you will want to change this, I just have it as pass. And then we'll paste it one more time and we'll have app.config, and instead of this time we'll have force, so this will force us to log in before we can actually see the security feed, and then we'll enable it to be true, so we'll say true. Yeah, so this is our authentication. Then we can create a variable called basic underscore auth equals basic auth, and then we can pass in our app, and we can create, so we'll create an object or a variable to store in the time that we last sent an email. So this will, now as you might know, okay, wait, I just noticed that I named this wrong, so I just corrected the spelling there. So if I have given this a time interval of 600, now how will the program know that this time interval has been completed or when to send an email? So for that we'll create a variable called last sent, so this will store the time when the email was last sent, and then based on that it will calculate whether or not 600 seconds or milliseconds have passed. So we'll initialize it to 0, so it will be in 0 initially, and then we'll create a method which is called check for updates. Now this method will simply, as its name suggests, it will check for updates. So we'll use the global last sent value. Then we'll have the while loop, so we'll, inside the while loop we'll type in the code for checking the values or checking for updates. So we'll have try, make sure you use proper indentation over here, because if you don't you will get errors. So we have frame and found object which are returned from video camera.get object, as you might remember, because we had the video in the camera, we had a method called get object, and we are using that method to get frame and found object. So it will make more sense when I type it in, so let me just type in here. So frame comma found object equals video camera, this is the name of our object that we created over here. So video camera dot get object, okay, it was underscore, my bad, get object, and as a parameter we need to pass in the object classifier, and then we will check if the found object, so this will basically go to the camera what you call the file, and then go to the get object method and check if any detection has been made, or if there is a face, if it detects a face in the frame, and then based on that it will return the frame and the found object variable. So now we need to check if the found object variable is true, then we need to send an email, otherwise not. So we'll do that. So if found object, and so we need to make sure that it has found an object, and also the fact that the time, we have this email update time interval, right? So we need to make sure that this, let's say if it has just sent an email last minute, it doesn't have to send it again. So that's why we're checking for it again. So we'll have time, this will get the current time, and minus last sent is greater than email. I'll just copy this from here and paste it here. So yeah, we'll only send an email if the time interval is greater than the email update interval, and also if an object is found. So if either of these condition is false, then email won't be sent. So, and if we are sending an email, so which means that both these conditions are true, we will update our last sent. So we will update our last sent to be the current time, so that when we go to the next iteration of this loop, we get the updated value of last sent. And then we will just say send email, because we imported this method from mail, so we can just call it directly. We can say send email, and then as a parameter we'll pass in the frame. And finally we can have a print message with for us to know that an email has been sent. So we can say email sent. Okay, yep. And since it is in a try catch, in try statement, we'll need to have the except block, so we can catch any exception that occurs in the except block. So except, and then if we have any error, we can just print error. Okay, we can just simply say error, and then we can concatenate it maybe with the error information. So we can say, yeah, we can do something like this. So not in here but outside this. So we can say sys dot exc underscore info. So this will get us the error info, and 0. So this will give us the error info. And here we pass in the app.route, and then this is what the default. So whenever the user logs into localhost and :5000, this is what we will be showing now. So then we will also have basic auth for that. So basic underscore auth dot required, and then we have our index method, which will just render the index.html for us. So we have index, and this will do nothing more than just rendering the index.html for us. So just one line method. So we'll just say return render underscore template, and then within parentheses we can pass in the name of our file. So by default, when you call render template, it goes and looking for inside the templates folder. So if you don't have the templates folder, it will probably give you an error. So make sure you have a templates folder, and then inside the templates folder over here you need to pass in the name of the file, that is where you want, or whatever you want to render on the screen. So we want to have index.html, So we do that. Then we have the, so we are almost done, we're reaching towards the end of today's session. So this is just a few lines of code more, and then we can go to the testing of the code. So we can have def and gen camera, and what it will do is it will get frames from the camera regularly. So it will, this is basically to kind of show like show a video, so it gets frames so quickly one by one after the other that it gives an effect that it's a video being played, not pictures that are getting changed. So we have this, and then we have while true, so it's an infinite loop, and then within the infinite loop we capture the frame. So frame equals camera dot get underscore frame. As you might know, remember that this get frame method is from our camera.py. So yeah, and then what we can say is we can yield. So yield is used when you temporarily want to return a value. So we'll say yield, then we'll pass in this long command. So it's b and then single quote dash dash frame backslash r backslash n single quote space b single quote content dash type and colon, and then you can pass an image forward slash jpeg and backslash r backslash r backslash n backslash r backslash n, and then you can end this, and we can add plus frame and plus b again this and backslash r backslash n backslash r backslash n. Yep. So yeah, this is our generate method. Then we can have another app.route. So we can have app.route for video feed. So we can have something like this. We can say forward slash, so video feed, video underscore feed. This is what we had in our index.html. If you remember in the beginning when I showed you the index.html, and we had this inside our index.html. So this is something you might want to note. Then we'll create a method for video feed. So we had the video feed method inside the HTML index.html. So video feed, video underscore feed is, it will return a response of this method. So gen video, okay, video camera, and then another parameter is the mime type equals multipart forward slash x dash mixed dash replace semicolon, and then boundary equals frame. Yeah, so this is this. Then finally we have if underscore name equal main, then we will start the thread. So this is where we do the multi-threading. So threading dot thread, and then we have the target, which will take our method. So target is check for updates. Yes, this method will be run as a separate thread so that we don't block the running of our program. So we have check for reading, no, check for updates, sorry for that. Check for updates, oh, sorry, not updates, objects. Oh, what's happening? Okay, check for updates, and then it does not take any argument, so we'll just say args equal and then open and close parentheses, and then we'll start the daemon. So we can say t dot daemon equals true, and then t dot start, okay, and finally we can say app dot run, and then pass in the IP address, which will be our local host. So host equals, we'll pass in the host, so in our case we are the host, so 0.0.0.0, and debug, we'll keep debug to false, but you can keep it true as well. So yep, so let's save it, and hopefully we don't get any error, but if we get, we just solve it right now, and let's see how this thing works. So save this code, head back to our terminal, and okay, so we can see, let's clear this a bit, and maybe I'll just zoom in a bit so it's easier for you to see. Okay, and then we can see the contents of this folders, and we want to run main.py. So this is the file that you want to run, so python3 and then main.py. okay, so we get an indentation error in main.py, so we'll need to see that. Okay, where does it say check for updates? Okay, my bad, this didn't have to be indented, so what I can do is, okay, let me try with this. Okay, yep, it worked, and hopefully everything else is fine. You can go back here and try running it again. Okay, there is invalid syntax. Okay, my bad, I had the print statement without the quotation mark, so this is embarrassing. Let me just quickly go and fix that up. So it was mail.py. So what happened is I missed the quotation marks, and okay, well, it was not mail.py, it was main.py itself. So main.py, and then we had an error over the print statement here, so just add quotation marks here and it should be fine. Save it, and let's run the code again and see which error we get this time. Okay, I guess we don't get any error this time, which is a good thing. So I'll just minimize all the others. Okay, we get another error, no module named smtplib. Okay, that is because I spelled smtp wrong. I spelled it smpt instead of smtp, so you might want to check your spellings again when typing in. So yeah, let's just go and change that. Now this time it's in mail.py, so change this to smtp instead of smpt, so smtplib. Save it and head back to our terminal. Okay, So it should work if we don't get another error. Wow, we get another error, which is somewhere in main.py, and sorry, where in camera.py we have an error. So let me just quickly check what error we have there. So what's the line we have the error in? Line 14, video camera object has no attribute vs. Okay, wait, let me go back to my camera.py and see what's the error. So we have self.vs equals, okay, this is because I spelled this wrong, so it should be pi video stream, and I have for some reason video, so it should be this pi video stream dot start, and then we should be fine. So many errors we've got, sorry for that. And at this point I'm just waiting for more errors. Let's hope we don't get an error this time. No, we did get an error again. Okay, so this time it's in main.py again, and check for updates, check for objects is not defined. Maybe I named it something else. Okay, I need to check that. Okay, let's go back to our main.py, and where was this? Okay, I didn't open main.py. Main.py is here, so this is our main.py, and then we have check for objects, right? Wait, where did we have check for objects? I think I named it something else. Oh, I named it check for updates and not objects, so that's what's the error is about. So it should be check for updates and not objects. And now we shouldn't get at least this error. We should not get. Run it again. It takes some time to run, and then we have a lot of errors. Okay, it's probably because I did something wrong with the class over here. So where did I go wrong? It's probably somewhere in here. Where is it? Where is it? Anyways, I'll need to check what this error is, but in the meanwhile I had this code already written before as well, so we can head into that and try and run that one. So we can stop this execution, we will go into that folder, so we can go to cd dot and then you can go to cd cam ls and then python 3 main.py. Let's try running this. So anyways, the codes and all the files and the models and everything will be will be there on our GitHub page, so make sure you check it. So now it's finally running. We have this, so if you want to access it, we can just go to our, oh, not this one, oh, it's already open here. We'll go here. So we have localhost and then port 5000. So just reload this page and you should get this. So right now you're getting a blank screen because my camera was placed on, okay, let's try and run it again. Wait, I think I unplugged the camera module by mistake. So let's run the code again. it takes some time to start it. Oh, we were in the wrong tab all this while. So yeah, we should get here. So if we reload the page, then yep, you can see me. So there's a bit of a lag between the camera, and this is because of me using VNC. So if I use the monitor, or if you were to use not used VNC, you would see the picture without that much of a lag. And yeah, so if I show it my face, I should expect an email. So yes, let me just go to my email, and yeah, so here it is. I have an email. Wait, let me check if I have an email. Okay, not yet. Okay, let's go back here and try it out again. So if I show it my face, it should send an email. I mean, this should work. So maybe it should work. Oh yeah, so here we have an email which says security update. So it's timed at 12:09 and currently the time is 12:09. So yeah, this is the email that I just received, and it has my face and then the frame. It kind of made the bounding box at the wrong place, but that's probably because while I move my head quickly, but it gets the thing done. So yeah, that's about it. And then when you're using in your house or somewhere like that, you would probably want to use a detection model, not the face recognition but the upper body or probably the full body detection, to make sure, let's say if some thief has come into your house, so you might want to have the full body detection on instead of just the face detection. So yeah, that's one thing. And then yep, so that's pretty much it. We're done for today's workshop. And do leave comments on how you like this video, and subscribe to our channel if you want to see more workshops or interesting tech stuff. And you'll also hit the bell icon to be updated about when we post a new video or if there's anything happening. And yep, that's pretty much it. See you next time. Bye bye.